Okay, so we're going to talk about the next unit is combinations. That's 1D, and I wasn't sure how to present it, and I typed it out. So I said, you know what? Let me just read this through with you. So um, a permutations, it's n objects arranged r at a time. Order matters. So how many words can be made from the word bench? And we know from our practice it's 5 factorial. 5 times 4 times 3 times 2 times 1. Now, I could ask you how many letter words can be made from bench? 2 letter words can be made from the word bench. And you say, okay, you know, I have I have 2 spaces, 1, 2, and for the first space I have 5. For the next available letter I have 4. So that's 5 times 4. But from our math exercises, we know that's 5 factorial divided by 3 factorial. That was an interesting problem that showed up. So I want, and you might wonder, oh, you know what? 5 minus 2 is 3. Is that a coincidence or not? Well, let's try another example. How many 3-letter words can be made from the word facetious? I like the word facetious because it has all the vowels and they're in alphabetical order. But anyway, there's 9 letters. So I make my 3 spaces, and I have 9 times 8 times 7. And once again, I know, oh, wait a minute. From the exercise, I know it's 9 factorial divided by 6 factorial. Not a coincidence. It turns out that n objects arranged r at a time, which is written as npr, is n factorial over n minus r factorial. It's kind of interesting. Sorry. So that's permutations. But today's lesson, we want to talk about combinations. And the idea of combinations is that it's n objects chosen at r at a time. The notation is, the notation is NCR, or open parentheses NR, and the formula is NPR divided by R factorial, or N factorial divided by R factorial over N minus R factorial. Now, I want to talk about why we're dividing by R factorial. So what we're going to do is we're going to compare 6p2 and 6c2, and then we're going to compare 6p3 and 6c3. So we're going to look at 6 letters, A, B, C, D, E, F, and I'm going to choose, we're going to start with 6p2. So I have AB, AC, AD, AE, AF, BA, BC, BD, BE, BF, dot, dot, dot. I notice that each letter has 5 pairs, and because there's 6 letters, it's 30 pairs. Now, 6c2, if order doesn't matter, then AB and BA are the same, AC and CA are the same, so I can cut everything in half, and I have 15 combinations. Okay. But we know from the formula, I'm not dividing by 2, I'm dividing by 2 factorial. So let's see what's going on with 6p3. Well, I start to draw them out. ABC, ABD, ABE, ABF, ACB, ACD, ACE, ACF, and so on and so forth. I'm not going to write all them out. All right. And I know that there's 60 because 6 times 5 times 4 is, it's 120. Right? Now, but how do I look at that, just by counting? Well, I know that each pair has 4 connections. AB, AC, AB has C, D, E, F. AC has B, D, E, F. AD has B, C, E, F. So I know that each pair has 4 connections. In the previous problem, we know that there's 30 pairs, 6p2, and 30 pairs having 4 each, there's a total of 120 arrangements. Now, you might think that we divide out by 3 to eliminate the repetitions, but if you think about it, it's more than that. So, for example, I take the letters A, B, C. How many triples are eliminated with ABC? Well, we know it's 6. ABC, ACB, BAC, BCA, and CAB, and CBA. So it's 6. So if 2 goes to 2 and 3 goes to 6, we know it's n goes to n factorial. Actually, it should be r. You know what? I could change that. It actually should be r goes to r factorial. So hence in the formula, we divide out the 6 or the n factorial for combinations. So what I'd like you to do is I would like you to practice by hand the following 4 choose 2, 7 choose 3, 8 choose 1, n choose 1, 6 choose 0, n choose 0, 11 choose 10, and n choose n minus 1. Take a break, and then we'll work on these problems. Okay, we're back. Let's just go to, let's put a point in here, and let's paste the picture. Whoops. Oh no. So let's hold on a second. So let's get, that's a big picture. Let me shrink it down. Sorry. Okay, so the first is 4 choose 2. Let's see, 4 choose 2. So we know it's 4 factorial over 2 factorial times 4 minus 2 factorial. It's 4 factorial over 2 factorial times 2 factorial. 4, 3, 2, 1, 2, 1, 2, 1. That goes out with that. Final answer, 6. What's the next one? 7 choose 3. 7 factorial over 3 factorial times 7 minus 3 factorial, which is 7 factorial over 3 factorial over 4 factorial. Not a coincidence, the 7 and the 3. So it's 7 times 5 times 7 times 6 times 5 times 4 factorial over 3 times 2 times 1 times 4 factorial. Notice how I'm manipulating this. I'm seeing what I can do. The 4 factorial goes out with the 4 factorial. The 3, 2, 1 goes out with the 6. Final answer, 35. What's next? 8 choose 1. Let's see, 8 choose 1. Well, I know it's 8 factorial over 1 factorial times 7 factorial. Well, let's make this easy. I know this is 8 times 7 factorial over 1 times 7 factorial, 8. Next problem. The next problem is n choose 1. n choose 1. N factorial over 1 factorial times n minus 1 factorial. Well, that's n times n minus 1 factorial over 1 times n minus 1 factorial. Final answer, n. How many ways can I choose 8 things one at a time? 8. Interesting. Next question. 6 choose 0. How many ways can I not choose from 6 objects? Well, you might say, that's easy, Mr. Alley. The answer is 1. There's only one way to do nothing. Let's see. 6 factorial over 0 factorial times 6 minus 0 factorial. I don't think we discussed this. It turns out that 0 factorial is equal to 1. How many ways can you do nothing? 1. That's why 0 factorial is 1. So answer, 6 factorial over 6 factorial is 1. And then it turns out that n choose 0 is 1. Another thing you should think about it, n choose n. N choose n. Let's see, n factorial over over n factorial times n minus n factorial. That goes out with that. We have 1. How many ways can I choose like n objects from n objects? There's only one way. What's the next problem? 11 choose 10. 11 choose n. Those some big numbers. 11 choose 10. Well, we have 11 factorial over 10 factorial times 11 minus 10. That's not so bad, right? Because this is 1. And we know it's 11 times 10 factorial over 10 factorial times 1 factorial. That goes out with that. Final answer, 11. It turns out that n choose n minus 1 factorial. N choose n minus 1, which is n over n minus 1 times n minus 1 factorial is equal to n factorial over n minus 1 factorial times 1 factorial. You ready for the trick? Who's ready for the trick? Are you ready for the trick? Well, it becomes n factorial 1 factorial times n minus 1 factorial. I just switched these two around, and well, that was n choose 1. It turns out that 11 choose 10 is equal to 11 choose 1. So, for example, it turns out that 9 choose 8 is equal to 9 choose 1. It turns out that 13 choose 9 is equal to 13 choose 4. Okay, let's do some of these problems at the end. So I asked you to let's take a look at these problems. There are 5 girls and 4 boys in a class. How many ways can I choose 3 students? How many ways can I choose 5 students if 3 must be girls and the rest boys? How many ways can I choose 5 students if I have to have Arzu and Armani on the team, but not both? Pause. Okay, now we're back. So let's copy. Let's paste. You know what? Forgot that. So what do we know? So we know there's 9 kids in the class. So let's go back. Let's change the color to black. We know from the example that there's 9 kids in the class, and I need to choose 3. Okay, that's easy. 9 factorial over 3 factorial times 6 factorial. 9 times 8 times 7 times 6 factorial over 3 times 2 times 1 times 6 factorial. I'm just writing the numbers out. Let's see. That goes out with that. The 2 goes out with the 8, leaving me with a 4. The 3 goes out with the 9, leaving me with a 3. And I have 21 times 4, 84 possible teams. Yeah. Okay. Next. How many ways can I choose 5 students if 3 must be girls and the rest boys? Well, this is the product principle. So from 5 girls, I choose 3, and from 4 boys, I choose 2. That's the idea. 5 choose 3 times 4 choose 2. And so what's 5 choose 3? Well, we did that before. What is 5 choose 3? 5 times 4 times 4 fact. Sorry. 5 times 4 times 3 factorial over 3 times 2 times 1 times 2 factorial. Sorry. That goes out with that. This goes out with this, leaving me with 2. This is 10. And 4 choose 2. Let's see. 4 factorial over 2 factorial times 2 factorial. 4, 3, 2, 1 over 2, 1. 2, 1. Sorry, I'm way down. That goes out with that. 2 goes out. This is 6. 10 times 6, 60 teams. If 3 of them have to be girls and 2 have to be boys. Now, the last question is a restraint, but it's not so bad. So let's look at the last question. How many ways can I choose 5 students if I have to have Arzu or Amani on the team, but not both? So let's think about it. Once again, this is the product principle. So let's take a look at the first team. 1, 2, 3, 4, 5. So let's start with I can have Armani. Let's start with Arzu. So there's one choice for Arzu. What's going on here? How many students are left for the last 4 positions? Well, there's 9 kids, and I chose Arzu, but I can't have Amani, so it's 7 choose 3. 7 choose 3. Or this is Arzu, right? What's going on here? Or 2, 3, 4, 5. Yeah, I can have Amani and from I have to choose 7 or 4. Yes. Sorry, that's 7 choose 4. Once again, I only have 7 to choose from, and I have to choose 4 of them. So that's the idea. There's 2 possibilities. Either I have Arzu, and then from 7 I choose 4, or I have 1 for Armani, and from the remaining 7, because Arzu's not part of this anymore, I can choose 4. Well, what's 7 choose 4? 7 factorial over 4 factorial times 3 factorial is 7 times 6 times 5 times 4 factorial over 4 factorial times 3 times 2 times 1. 4 factorial goes out with 4 factorial. 3, 2, 1 goes out with 6. It's 35. Final answer, 70. Okay, work on 1D.